Just a refresher. So C, we have 2i times 3 plus I. So I have to distribute that 2i. So 2i times 3 is 6i. And then 2i times I is 2i squared. Our answer is never going to have an I squared or an I cubed or an I to the fourth. The only answer it can ever have is just an I. So when I look at this I squared, I know I have to fix that. Well, we established yesterday the imaginary unit is equal to the square root of -1. So then what would I squared be equal to? Well, if I square both sides, that tells me I squared is equal to -1. Because when you square a square root, those are inverse operations. They cancel. So if I squared is the same thing as -1, I'm going to plug in -1 for I squared. So that tells me 6i plus 2 times -1, which is -2 plus 6i. I'm just going to write it the way we have been, a plus bi, where you have the real number part first, the imaginary part second. On D, you've got 3i, all of it squared. So that means you have to square the 3 and square the I. So that becomes 9i squared. But we just established I squared is the same thing as -1. So that's 9 times -1, which is -9. Next one, E is -3i, all of that squared. So that's going to give me -3 squared times I squared, which is 9i squared, which is 9 times -1, which is -9. And then on F here, we have to distribute. So 5 times 5 is 25. 5 times positive 2i is 10i. Negative 2i times 5 is -10i. Negative 2i times 2i is -4i squared. 10i minus 10i goes to 0. -4i squared, that's -4 times -1, which is +4. So I've got 25 plus 4, which is 29. So something interesting happened right there. So if you look at this, think about when you factor something. What does this look like it's factored to be? Difference of perfect squares is the way that this factors to be. And you see when I distributed, I had 25 minus 4i squared, and the middle two terms went away. Okay, these things are called conjugates of each other. Have you heard that word before? Conjugate. So if you multiply conjugates by each other, then the two middle terms always go away. That's a property that happens. Because think about what happens with a difference of perfect squares. Right? You distribute, the two middle ones go away. So we call those conjugates. And that's going to be very useful for us here in just a second. Okay, so the thing we want to talk about now are the different powers of I. So I told you before, you can never have any answer besides I to the first. So there's a pattern that goes through the I's that, let's look at what it is. You may have had to memorize this before, but I hate memorizing stuff. All that I have memorized is I know I is equal to the square root of -1. That's the only thing I know. Now, if I square both sides, we looked at that just a second ago, that became I squared was equal to -1. And I'll just assume that you all saw where that came from the first time, so there's no reason to go over it again. Okay, what if I multiplied both sides by I? Then that becomes I times I squared, which is I cubed. And then what happens if I multiply -1 by I? Well, that's going to be -1 times I, right, which gives just -I. So I cubed is -I. And now if I multiply both of those by I, that becomes I to the fourth equals yes, because if I multiply by I, that becomes negative I squared. If you square, I squared is the same thing as negative 1, so it becomes minus negative 1, which is positive 1. And that pattern just repeats itself. If you look at I to the fifth, what happens if you multiply 1 by I? Well, it just is I. And you see how this is what I started with. I to the fifth is I to the first, and the pattern repeats. If I multiply both of these by I, that becomes I to the sixth equals I squared. We know I squared is the same thing as negative 1. So you see how I'm just stuck in that pattern over and over and over. So there's only 4 different possibilities, and right there they all are. Now, another way that you can write I to the fourth, that can also be written as I to the 0 power, because anything to the 0 power is 1, and that may be a little bit more beneficial for us. Okay, so let's say this first one is I to the 42nd. That's what I'm going with. That's what it looks like. So we want to simplify I to the 42nd and see what that becomes. Okay, so we could keep going the pattern and see where 42 is, but the easy way to do it is just divide. 42 divided by 4 goes in there one time, 4, 0, bring down the 2. It can't go in there any times. So 42 divided by 4 is 10 with a remainder of 2. Now, if you do it in your calculator, you're going to get 0.5. So you're going to have to know that that is 2/4, right? Keep the pattern going. So I to the 42nd is the same thing as I to the second power, because that's what the remainder was. Because to the 0 power, to the 4th, to the 8th, to the 12th, 16th, 20th, 24th, 28th, 32nd, 36th, 40th are all repeating over and over. That's the 4th. So think about the 40th gets you back to I to the 0. And then I to the 1st would be the 41st power. I to the 2nd is the 42nd power. And then what is I to the 2nd equal to? That's equal to negative 1. So the next one, I think that's I to the negative 85th. It doesn't, as long as we are working the same thing. So when we have negative exponents, we can rewrite those in the denominator as a positive exponent. So I need to do that first. So this is 1 over I to the 85th power. And then I need to determine what is I to the 85th power. So I'm going to divide. 85 divided by 4, that's 2, 1 with a remainder of 1. If you can't tell, I've been working on my 7th grade math recently. I'm getting really good at dividing again. Okay, and so that gives me a remainder of 1. So this is the same thing as 1 over I to the first. Which is what we're going to leave it as, 1 over I. The division of complex numbers. The complex numbers a plus bi and a minus bi are called complex conjugates of each other. So example 4, we're going to talk about complex conjugates. We want to find the product of the given complex number and its conjugate. So the first thing we're going to do is we're going to practice finding the conjugate and then multiplying conjugates together. So 3 minus I, the conjugate of that would be 3 plus I. Just change the sign in the middle. And then I'm going to distribute. 3 times 3 is 9. 3 times I, 3I. Negative I times 3, negative 3I. Negative I times I is negative I squared, which is the same thing as negative 1, which is 10. So what happened when we multiply conjugates? The two middle terms went to 0. That always happens with conjugates. So you can eventually start skipping that step when you realize it. Next, you've got 4 plus 2i. I can multiply that by 4 minus 2i. That would be the conjugate. Can y'all see that? Okay, the yellow. Okay. On my old projector it didn't work, but I think it works better in here. 4 times 4 is 16. 4 times negative 2i is negative 8i. 2i times 4 is positive 8i, which go to 0. 2i times negative 2i is negative 4i squared. So this is 16 minus 4 times negative 1, which is 16 plus 4, which is 20. And the last one is just negative I. So what's the conjugate of negative I? It's positive I. If you want to think about it as a complex number, we could write this as 0 minus I. So its conjugate would be 0 plus I. And you could distribute, but that's kind of pointless because a bunch of them are multiplied by 0, right? Negative I times positive I is negative I squared, which is negative negative 1, which is positive 1. So what happened when we multiplied a complex number by its conjugate? What happened in general?
The
Middle terms went away with a conjugate. Okay, what else do you notice happened? We multiplied two complex numbers.
They became one whole number.
Yeah, it just became real, right? The imaginary part went away every time because the I became an I squared, and then it became just a real number. So when we multiply two complex numbers, if they're conjugates of each other, then you make that number become a real number, which is going to be really beneficial for you. If A and B are real numbers, then the product of A plus BI and its conjugate A minus BI is the real number A squared plus B squared. So this is what happens in symbols. A plus BI times A minus BI. A times A is A squared. BI times negative BI is negative B squared I squared. But I squared is negative 1, so negative, negative, positive. Anyways, this is just what we've been doing, right? That's all it is in symbols. The two middle terms went away. You just multiply the first and the last and square them. Okay, so now we're going to have to divide complex numbers. So this is, I'm going to say that's 5 minus I divided by 2 plus I. So y'all can just put that in your calculator, can't you? Just put that in your calculator. Y'all know the imaginary button? Oh, darn. Well, that's okay. We can just do it old school. So I've got 5 minus I on the inside, 2 plus I on the outside. How many times can 2 plus I go into 5 minus I? That's not very good either, is it? No. How do we like dividing by complex numbers?
Oh, I don't like it.
I don't like it either, so guess what I can do?
Not do it.
Get rid of the complex number. If only I knew a way to change a complex number to a real number.
Too unfortunate. Do the thing that we did last time.
What's that?
Conjugate, multiply by conjugate.
Oh, okay. So what's the conjugate here? What am I going to multiply by? It's in the denominator. I need the denominator to be a real number because I can divide the numerator being complex. That doesn't matter. So 2 plus I is in the denominator, so I need to multiply by 2 minus I. Okay, but if I just multiply the denominator by something, it's going to change the entire fraction. I'm going to have a totally different fraction.
That's what we wanted to do.
We want to change its form, but we don't want to change the number. If you had half a pizza and then we multiplied by 8 down here,
We have a lot.
you just have the 16th of a pizza. That's not good.
And then
You have to
we a
multiply
lot
by
less.
8 on top too,
Well, why? What does that do?
And that can be called pizza.
because then it just makes it a bigger fraction.
What do you mean a bigger
Then
fraction?
it's 8 over 16, it's still 1/2.
Yeah. So when you multiply by 8 over 8, what is it we're really doing?
One.
Multiplying by 1. Does that change the number? No, multiplying by 1 never changes the number, it just changes the form. So multiply by 2 minus I in the denominator, I'm going to do it in the numerator. So I don't change the number, I just change its appearance. I change the form. So now in the numerator we have to distribute. 8 times 2 is 16. 8 times negative I is negative 8I. Negative I times 2 is negative 2I. And then negative I times negative I is positive I squared. Now in the denominator, 2 times 2 is 4. 2 times negative I, negative 2I. I times 2, positive 2I. Those go to 0. Conjugates. I times negative I is negative I squared. Now I'm going to group my like terms and do some substitutions. 8I minus 2I is negative 10I. That leaves me with 16 plus I squared. Well, plus I squared is the same thing as negative 1. 16 minus 1 is 15. Then the denominator, I squared, is negative 1. So 4 minus negative 1 is 5. Hello. Now can I divide this? 15 divided by 5 is 3.
It's on your desk.
Do you need me? Okay.
I forgot my phone and I come down here to get it, it's just open, it's on my desk.
You need one of those, need your Apple Watch. You can ding it
Wait, how do you think it?
with your Apple Watch. You can just ding it. You can do Find My iPhone. Okay, B, here we go. We've got 1 over 5 minus 4I. Trust me, if I didn't have to take any other subjects, I wouldn't have. But I have to. So I need to multiply by the conjugate. What is the conjugate? And why am I multiplying by the conjugate? No.
Because it makes.
Because it makes the magic happen.
Because the denominator will now become a real number. We can't divide by an imaginary number, so we're going to make it real. Now distribute. The numerator is 5 plus 4I. The denominator is 25 minus 16I squared. I squared is the same thing as negative 1. So that is 25 plus 16, which is 41. So you can leave it like this, or you could break it apart as 5 over 41 plus 4 over 41 times I. Those are the same thing.
Is that just an I?
Yes, just an I.
Do we do like negative I?
Yeah, let's multiply by negative I.
Or just, yeah, that'll work. I think.
Okay, so now then in the numerator that becomes negative 3I plus 2I squared over negative I squared.
So that's over 1, and it's just.
So that is negative 3I minus 2 over 1. which we can write as negative 3i minus 2, which is negative 2 minus 3i. Now we want to simplify negative radicals.
To that plus, not to that 8.
Okay, so I've got the square root of negative 8 plus the square root of negative 18. So the first thing I'm going to do is I'm going to get rid of the negative right off the bat. I can write this, so here's the real technical steps. Negative 8 is the same thing as negative 1 times 8, which I can then break apart as the square root of negative 1 times the square root of 8. Well, the square root of negative 1 is I. Okay, that's what's happening. But I'm not going to write that out every single time. I'm just going to pull the negative out and make it an I. But this is the steps. This is what we are doing. So this becomes I times the square root of 8 plus I times the square root of 18. 8 is the same thing as 4 times 2, which is 2 radical 2. And then the square root of 18 is 9 times 2, which is 3 radical 2. Now my radicals match. 3 plus 2 is 5i radical 2. Okay, next we have negative 4 plus the square root of negative 50 over 4. Looks as good as anything to me. Okay, so I need to fix the square root of negative 50. So this is negative 4 over 4 plus I radical 50 over 4. Well, radical 50 is the same thing as 5 radical 2. So that is negative 1 plus 5i radical 2 over 4. I'm finished. Okay, on to the next section. It tells me to solve an equation by factoring. So we're going to solve this equation. So we did a factoring worksheet earlier this year. The difference with these is now the polynomial is going to be equal to 0. So I need to factor and then solve. So there are 4 terms. So my automatic thing I'm going to try to do is to factor by grouping. Anytime I see 4 terms, I'm automatically going to try grouping. The GCF of the first set of parentheses is x squared. That leaves me with x plus 3. The GCF of the second set of parentheses is 1. That leaves me with x plus 3. Now the parentheses match. Perfect. That leaves me with x squared plus 1 times x plus 3, and set that equal to 0. Now this is a very important trait that a lot of times goes overlooked with factoring. What is it we're actually doing? I'm telling you that this thing times this thing has to be 0. Well, that has a really nice property. What do you know must be true of one of these two things? One of these two has to be 0. If it's not 0, then they wouldn't multiply to be 0. And people think, oh, well, that's just pointless. Who cares? Okay, well, if I had this is, don't write this down. This is just a thought bubble. If I had x squared plus 1 times x plus 3 was equal to 1, if I multiply these two things together, does that mean one of these two is 1? No, I could multiply 2 times a half. I can multiply 3 times a third, 4 times a fourth, 5 times a fifth, 6 times a sixth. You follow? There's nothing this tells me. I'll multiply these two things to get 1, big whoop. They could be anything. I know nothing. But if I multiply these two things together and get 0, one of them has to be 0. There's no other way you can get a 0 unless something you're multiplying by is 0. Nice fact. So that means I know one of these two parentheses must be 0. Either the first one must be 0 or the second one must be 0. And now I can solve for x. So I'm going to do the second one first because it's a little more straightforward. This gives me x is equal to -3, so that is a possibility. And that is my only real possibility. Okay? Make sure you read the directions carefully on the homework problems. Some of them will tell you to give the real solutions. Some will tell you to give all complex solutions. So when I solve over here, this gives me x squared is equal to -1. Then I take a square root, and that's going to give me x equals plus or minus I, because the square root of -1 is I. And remember, when you choose to take a square root, you must always account for the plus or minus. So here we've got two terms. So my first thing I'm thinking is, I'm a little kid. The first thing I'm thinking is there a GCF? Well, I look, they both have a y, so I know I can factor out at least a y. It turns out it could be a y squared. And then they both have a number, so is there a GCF there? Well, I'm going to try 3. Well, I know 3 works here. Does 3 work for this number? Do you know how to tell? Huh? You just divide in your calculator? I guess that's as quick as anything. I've been teaching my 7th graders how to tell without a calculator. You know how to tell if this is divisible by 3? Add the digits. 4 plus 8 is 12. Is 12 divisible by 3? Yes, then this number is divisible by 3. So they both can factor out a 3. So that leaves me with a y squared minus 16 is equal to 0. Now it wants me to continue factoring. This is the difference of perfect squares. So I can factor that to be y plus 4 times y minus 4. So now 3 things multiply to be 0. Well, guess what? One of the 3 things has to actually be 0. So 3y squared equals 0, y plus 4 equals 0, or y minus 4 equals 0. So that tells me y is equal to 4, y is equal to -4. Divide by 3, take a square root. Y equals plus or minus 0, which is just a 0.
If you plug all of them in, will they,
Yes.
will they all work?
Yes.
Just one?
They all work.
Will any number work?
No. Get rid of the radical. I need to square that side. Well, it's an equation. If you square one side, you're going to have to square the other side. Keeps it balanced. So when you square a square root, those are inverse operations. That cancels, and you're left with x minus 2. Now on the right side, we're squaring all of that. So if I square x minus 2, that means I have to multiply x minus 2 times x minus 2. When I distribute, that gives me x squared minus 4x plus 4. And now I have gotten rid of all of my radicals. Now I notice I have an x squared and an x. So let's get everything to one side because I want to set it equal to 0. Since I do not have an x to the first power only. So move everything over to one side, set it equal to 0. So I'm going to move stuff this way because that keeps my x squared positive. So that gives me x squared minus 4x plus 4 minus x plus 2 equals 0. And now combine like terms. X squared minus 5x plus 6 equals 0. And so either you can see what this factors to be, or you can do a times c. This one's pretty straightforward. It's x minus 2 times x minus 3 equals 0. So 2 things multiply to be 0. That means either the first one is 0 or the second one is 0, which means x is 2 or x is 3. And just remember what it asks for. It asks for real solutions. Both of these are real numbers, so they both are a solution. If one was imaginary, I would exclude that from my answer. So next one, to kind of give us a hint, is we're going to have to square each side twice. So I'm told to solve the square root of 2x plus 1 minus the square root of x equals 1. So I want to square those radicals to get rid of the square root, which means I have to square the other side. One thing you can't do, you can't just square this term and then this term, okay? When you square something, you have to do it to the entire side. So think about squaring all of that that's on the left. So that means I'm multiplying it by itself. So that's going to be the square root of 2x plus 1 minus the square root of x times the square root of 2x plus 1 minus the square root of x. That's going to be equal to 1 squared, which is just 1. Thank you for making the right side easy. Now we distribute square root of 2x plus 1 times the square root of 2x plus 1. What does that multiply to be?
Well, I thought that if we were to square it, we would just take off like the square root from
I just said you can't square the first and square the last because there's the two middle terms that you have to multiply. You're not allowed to just square the first and square the last. It's not how it works.
The first would just be a regular 2x plus 1, wouldn't it? Because it gets squared and then the radical does not.
It's when you multiply radical by radical, what we're really doing is we're multiplying everything underneath there. So if you want to get real technical, don't write this down, just pay attention. That'd be the square root of 2x plus 1 times 2x plus 1. Well, what is 2x plus 1 times 2x plus 1? That's 2x plus 1 squared. So you're square rooting something that's squared. Those are inverse operations. They cancel, goes to 1. So you're left with just 2x plus 1. So the square root of 2x plus 1 times the square root of 2x plus 1 is just 2x plus 1. Now distribute here, outside. That's going to give me
3x plus 1.
negative square root of 2x plus 1 times x. And we'll just leave it like that for the time being. I could distribute that out, but it's not really going to make it any prettier. So I'm just going to leave it. Now multiply on the inside. What does that give me? Negative square root 2x plus 1 times x. And then multiply the last two terms. Negative times a negative is positive. Square root of x times the square root of x is x. And so all that should be equal to 0. I'm sorry, equal to 1. Okay, so let's group some like terms together. So I've got 2x. I've got nothing to combine that with. I do. I've got 2x plus x, right, is on the same side. So that's going to give me 3x. Then I've got this plus 1. And then look at my radicals. I've got a negative radical 2x plus 1 times x and a negative radical 2x plus 1 times x. They have the exact same thing underneath the radicals. So that means you can think about that as being just a big variable. So what if this was a u? So if I had a negative u minus u, that's going to be negative 2 of those u's, right? We combine the coefficients. So that's going to give negative 2, and then instead of u, we're actually going to write out square root of 2x plus 1 times x is equal to 1. Okay, so I'm closer to having this solved because now instead of having 2 radicals, I just have 1 radical. So I need to square this again. But before I square the radical this time, I want to isolate the radical. Let's move everything that's not part of the radical over. So 3x plus 1, I'm going to move over here. So that leaves me with negative 2 square root of 2x plus 1 times x equals, that's going to become a negative 3x. I move the 1 over, it becomes negative. So I've already got a 1 minus a 1, which is 0. So no need to write that. Now I want to get rid of that radical, so I need to square both sides. Okay, so negative 2 squared is 4. What happens when we square a square root? Those cancel. So that leaves me with just what was underneath the square root. 2x plus 1 times x is equal to negative 3 squared is 9, x squared is x squared. Now go ahead and distribute. So what I'm going to be distributing, I've got 4 times x, so I know that's 4x. So I'm kind of treating that as this, okay? 4x. It's the same thing, it's just going to save me a step. 4x times 2x is 8x squared. 4x times 1 is 4x is equal to 9x squared. Now get everything to the same side. So I'm going to move to the right because that has my bigger coefficient of the x squared term. That's going to give me 9x squared minus 8x squared minus 4x is equal to 0, which tells me x squared minus 4x is equal to 0. So I've got two terms equal to 0, so I want to try to factor. Is there GCF? Yes. X minus 4 equals 0. So two things multiply to be 0. That means either the first thing is 0 or the second thing is 0. So my two possible solutions are x being 4 and x being 0. Okay, the first one here we're looking at, that says x to the 4/3 equals 625. So there's a real technical way we could go about solving this, but I know that that's not really y'all's style. So let's do the easy way. If I had x to the 4/3, and I want to get rid of that, I want to make it x to the first power. Well, when I have a power raised to a power, we can multiply. So what if I raised 4/3 to the 3/4? It's reciprocal, because what happens when we multiply reciprocals? We get a value of 1, and that's what we want, is x to the first power. So if I raise the left to the 3/4 power, I must raise the right side to the 3/4 power. That keeps my equation balanced. So 4/3 to the 3/4 is 1, that leaves x, and then 625 to the 3/4 power gives 125. Okay, the next one's very similar, but it has a couple more steps. So same idea, y minus 2 to the negative 5/2 power. I want to raise this to the reciprocal power, negative 2/5. If I raise one side to the negative 2/5 power, I must raise the other side to the negative 2/5 power. Negative 5/2 raised to the negative 2/5. That goes to 1. I'm left with y minus 2. Then I've got 32 raised to the negative 2/5 power, which would be 1 over 32, 1 over 2. So is it a fourth? Okay, now I want to solve for y. So y is being subtracted by 2, so I'm going to move that to the other side, make it positive. So 2 plus 1/4, which is 9/4. Here's the next one. Find all real and imaginary solutions to the equation and then check your answer. So I've got x to the 4th minus 10x squared plus 24 equals 0. So this looks like a trinomial, but my powers are a little off balance. Instead of being x to the 2nd, x to the 1st, and then a constant, I have an x to the 4th and x to a 2nd and a constant. I think we had some like this on the worksheet. What you have to make sure is all these powers just decrease. So like if this was x, this has to be an even power. X to the 4th, 6th, 8th, 10th, 12th, 14th. This one needs to be half of it. So if you had a 12th power, then a 6th power, and a constant, you can still factor it. If I had a 20th power, a 10th power, and a constant, you can still factor it. So I know because this is x to the 4th, x to the 2nd constant, it will factor. So I just have to trust blindly and treat it like it's any other trinomial, and it will all work out in the end. So what multiplies to be 24, but when subtracted gives 10? Well, 12 and 2 would be nice. 6 and 4 is nicer, right? 12 and 2 doesn't work because they would have to be different signs to make it 10, but they have to be the same sign to get positive 24. 6 and 4 can be the same sign, so that's what we like, and they're both going to be negative. So I've got a negative 6 and a negative 4. And now the leading coefficient should be, not coefficient, the leading term should be x squared and x squared, because I'm just taking a square root of this first power here. So now I've got two things multiplied together to equal 0. That's great news. That means either the first parenthesis has to be 0 or the second parenthesis has to be 0. So solve those out. This tells me x squared is equal to 6, which means x is equal to, so what did I do to get from there to there? I need to take a square root of both sides. The square root of x squared is x. What's the square root of 6? Don't forget, whenever you choose to take your own square root, you must always account for the positive or negative solution. Have I mentioned that yet? I think I have. Here's the next one. X squared minus 4 equals 0. Same thing. Solve it. X squared equals 4. Now I need to get rid of the square, so I take a square root. When I take a square root, I must always account for the positive or negative of my answer, which gives plus or minus 2. Okay, so what am I going to have to do here? I've got to solve an absolute value equation. Well, we've been working those in the past. To solve an absolute value equation, I need to make sure that absolute value is isolated, as it is here. Then, there are two possibilities. So I set up my two cases. So case 1 is what is underneath the radical, what's underneath the absolute value is equal to the positive value on the outside. Or case 2, what's underneath the absolute value is equal to the negative of what's on the outside. And since all my terms have an x, I'm going to get them all to one side. So I move the 9x over, it becomes negative. So x squared minus 8x minus 9x is negative 17x equals 0. Factor, GCF of x. So x times x minus 17 equals 0. Two things multiply to be 0. Either the first one is 0 or the second one is 0. So now I've got 0 as a solution. I've got 17 as a solution. Now let's try the other side. Get everything with an x to the same side. So I move the negative 9x over. It becomes positive 9x. So that leaves me with 8x plus x equals 0. Now factor. There's a GCF of x. That's x plus 1 equals 0. Two things multiply to be 0. Either the first thing is 0 or the second thing is 0. So x is negative 1 or x is 0. Now with an absolute value equation, I always think it's important to plug in your values and make sure that it works. So let's plug in 0 because that's a real easy one. So I plug in 0 squared minus 8 times 0. That is 0. The absolute value of 0 is 0. And then on the other side, 9 times 0 is 0. So 0 works. I'm going to try negative 1 next. Negative 1 squared is 1. Negative 8 times negative 1 is positive 8 equals 9 times negative 1. That tells me 9 equals negative 9. That does not work. So that means negative 1 is not a valid solution. Then plug in 17. 17 squared is 29779 256 289 289 minus 8 times 17. That's 170 minus 34, 136 equals 9 times 17, 170 minus 17 is 153. And so 289 minus 136 is 153 equals 153. So 17 works. So my only two solutions are 0 and 17. And it turns out in this case that negative 1 did not make the absolute value true. Okay, here we want to find all real and imaginary solutions. So we've got x to the 2/3 minus 2 equals x to the 1/3. So this kind of looks like a trinomial, but instead of being 2/3, instead of being to the second power and the first power, I've got to the 2/3 power and the 1/3 power. So very interesting. I'm thinking of a couple of ways that I might try to solve this. So first thing I'm going to do is I'm going to move everything over to the same side so I can really see it look like a trinomial. X to the 2/3 minus x to the 1/3 minus 2 is equal to 0. So if in the problem we had before where we had an x to the 4th and x to the 2nd and a constant, I told you just trust it and it would work out. Well, this one here's got the same pattern. X to the 2/3, what's half of that? X to the 1/3, and then a constant. So if you have enough faith, you could just treat this like any regular trinomial and solve it. Or we could do what's called a U-Substitution. I don't know which one. I don't know which one to try with y'all. Y'all give me no hope either way. Okay, I will. Which one do you want me to do first?
We've done the U-Substitution.
You have done a U-Substitution? Okay, well, let's try that. Okay, so we normally like for our things to be x to the first and x to the second. Well, we can't quite get that. So what I want to do instead is I want this term to be my first power, right? Because that's where normally x to the first power goes. So I'm going to say this. I'm going to say that u is equal to x to the 1/3 power. It's called a U-Substitution. So now everywhere they're used to say x to the 1/3, I can now say u. So instead of minus x to the 1/3, that's now going to be minus u minus 2 equals 0. And then let's deal with that x to the 2/3. So x to the 2/3 is the same thing as x to the 1/3 squared. Because a power to a power, we can multiply. So 1/3 times 2 gives 2/3. I'm just rewriting its form. But now I know it's x to the 1/3 squared. Instead of saying x to the 1/3, I'm calling that u. So I could think of this as being u squared. So now I have u squared minus u minus 2 equals 0. And then you just factor it. Multiplies to be -2, added or subtracted is -1. That's going to be minus 2 plus 1 equals 0. So that says u is equal to positive 2 or u is equal to -1. Now, do I care what u is equal to? No, I'm looking for x. So I have to substitute back in. So this is x to the 1/3 is equal to 2, and x to the 1/3 equals -1. And now let's do what we did before. How could I get rid of a 1/3 power? I could raise it to the 3rd power on both sides, because that's multiplying by the reciprocal. So that's going to tell me x is equal to 8. And then same thing on the other one. Raise it to the 3rd power. And that's going to tell me x is equal to -1. So I have two possible solutions. They are 8 and -1. So now we're going to be given an interval whose solution is that interval. Then we want to write an inequality that makes that true, and then write the solution set in interval notation. Oh, so that's for the last 4. So the first 4, we're given an interval, and we want to write the inequality for it, and then we want to graph it. So if we're looking for things that are between -infinity and 12, then that means 12 is the highest possible value. So our values are things that are less than 12. So the answer here is x is less than 12. Then if I were to graph that, I'm going to put 12 in the center. It is my number of interest. Since it's not included, I'm going to use a parenthesis, and things that are less than 12 go to the left. Now the next one, my answers are from -infinity up to -3. And -3 is in a brace, so that means it should be part of my answer. So I'm looking for all things that are less than or equal to -3. So my solution here is x is less than or equal to -3. Now if I were to graph that on a number line, My number of interest is -3. I'm going to put that in the center. Since I want it to be included, I'm going to put a brace instead of a parenthesis. And I'm shading everything less than -3, which means I'm going to the left. Because you're grown up. You do now. Okay, you look at the next one. We're looking from -7 to infinity. -7 to infinity. Well, this time -7 is on the left boundary. So that means it's the smallest possible value. So my solution set needs to be things that are bigger than -7. So we're looking here for x's that are bigger than or equal to, because it's in a brace, -7. So when I graph that, my point of interest is -7. I'm going to put a brace on -7 and shade everything that's bigger than -7. Can I skip 10? Do you get the gist of those? 11. Now we've got x being bigger than or equal to -8. So it wants me to write that in interval notation. So what's my solution? All things bigger than or equal to -8. That means -8 is the smallest value that works. So -8 would be my lower boundary. So what is my highest boundary? Well, there isn't one. So we put infinity. Have you seen the infinity symbol before? The sideways 8? Okay, good. Next, I've got x is less than 54. My solution is all things less than 54, which means 54 is the biggest number, and 54 does not work. Okay, so the smallest possible value is -infinity. The highest value is 54, but it's not included, so I put a parenthesis. Next one, x must be less than pi over 2. So pi over 2 is the greatest possible value that is included. So the smallest value is -infinity. The highest value is pi over 2. It's not included, so I put a parenthesis. And I'm going to skip 14. Okay, we're given an inequality to solve. 4x minus 18 is greater than 10. So, like we did before, I want to get x by itself. So I move 18 over, it becomes positive. That leaves me with 4x is greater than 28. Now x is being multiplied by 4, so I'm going to divide by 4, which tells me x is greater than 7. So now I've got 1/3 x minus 2 is less than 1/4 x plus 1. So I've got I've got variables on both sides. So to solve the inequality, I need to get the variables to one side, all the numbers to the other. So I'm going to move 1/4 x to the left. I'm going to move -2 to the right. That gives 1/3 x minus 1/4 x is less than 2 plus 1. So 1/3 minus 1/4 is 1/12. 2 plus 1 is 3. X is being multiplied by 1/12. So I'm going to multiply by the reciprocal on both sides, which tells me x is less than 36. What's the one rule that makes an inequality different than an equation?
When you divide or multiply by negatives, you have to swap the signs.
Yes. If you multiply or divide by a negative, you have to flip the direction of the inequality. Why? Okay. Let's talk about that for a minute. and then you can just go back on your merry way of just knowing what you're supposed to do and not why you're supposed to do it. Do you not like knowing why? You just trust people blindly? Why?
Because Miss Williams got mad at
No, but y'all don't trust people blindly.
Well, you're the teacher though, so.
Yeah, so you also went to school, so I don't think he'd give us something if they're like tough.
Okay, it's because we want all of our rules for equations to work with inequalities. That makes math really nice. If we can just do the exact same things with different kinds of math, that's always a good thing. So let's look at this for a second. Say I had this. X is greater than 1. What does this actually mean? My solution set, everything that makes this true is a number bigger than 1. 2, 3, 4, 5, 6, 7, 8 works. Things less than 1 do not work. 0, -1, -2, -3, -4. So you have, it's basically like we're dividing the numbers in half. This half works, this half doesn't. Every time with an inequality, how that works. But you can't divide infinity in half, but whatever. So if we want this to still be the same answer every time, what happens if I add 4 to both sides? Is this still my solution? If you plug in 2, does it work? 3, 4, 5. Yeah, 5 plus 4 is 9, and that's greater than 5. If I plug in something less than 1, does it not work? 0. Doesn't work. -1 doesn't work. -2 doesn't work. So this is still the answer here. I added something to both sides, it still kept it balanced. Okay? Well, what if I multiply both sides by something? Does it still work? Well, now this is 2x plus 4 is greater than 10. So if you plug in something bigger than 1, does it still make it true? 2. Yeah, 3. 2 times 3 is 6. 6 plus 4. No, I'm an idiot. God, I'm so stupid. See, here y'all go just going along with it. What did I not do? Distribute. If I plug in 2, 2 times 2 is 4. 4 plus 8 is 12, which is greater than 10. If I plug in 3, still works. 4 still works. 0 doesn't work. -1 doesn't work. So I haven't broken the inequality. It still works the same way I wanted it to work originally. What if I multiplied both sides by -1? Now -2x minus 8 is greater than -10. So I still want this to be my answer, because that's what I started the problem being the answer. And I just manipulated that all the way down. So if I plugged in 2, -2 times 2 is -4. -4 minus 8 is -12. Is -12 greater than -10? No. No. But I want 2 to work. I want 3 to work. -2 times 3 is -6. -6 minus 8 is -14. Is -14 greater than -10? No. I don't want 0 to work, but it does. I've completely flipped what works and what doesn't work. Now the other half is my answer. So to get it back to the correct half, I need to flip the inequality. Okay, so now if I had to solve this, -7 times z minus 7 is greater than 6z minus 3. First thing I notice on the left, I have parentheses, so I want to distribute. So -7 times z is -7z. -7 times -7 is positive 49. Is greater than 6z minus 3. Now get our variables on the same side. So I'm going to move 6z to the left. I'm going to move 49 to the right. So that becomes -7z minus 6z is greater than -3 minus 49. Combine like terms, that's -13z is greater than -52. Now divide by -13 on both sides. So that tells me z 4, And because we decided to divide by a negative 13, we have to flip the inequality, make it face the other direction. So my solution set are all numbers less than 4. Now here we have a compound inequality. So I've got 2 inequalities and then 1 variable in the middle. So I'm going to solve for the variable, and it has to stay in the middle when you have a compound inequality like this. So first thing, the x is being subtracted by 2, so I'm going to add 2 to all 3 parts of my inequality. So negative 6 plus 2 is negative 4. The middle becomes 2x, and then 2 plus 2 gives 4. Now x is being multiplied by 2, so I'm going to divide everything by 2. That tells me negative 2 is less than x, which is less than or equal to 2. So it's a compound inequality. The way I like to read it is if you read it the way you're supposed to, negative 2 is less than x is less than or equal to 2. Okay, but that kind of gets confusing in my head about what is x actually. So I always read from the x. This tells me x is greater than negative 2, but it has to be less than or equal to 2. So if you read from that x in both directions, it kind of makes it a little simpler as to what our solution set is. So it tells me to graph that on a number line. So my points of interest are negative 2 and positive 2. Now negative 2 is not included in my answer, so I'm going to put an open parenthesis. Positive 2 is included, so I'm going to put a brace, and then my solution set is everything between those, because x is bigger than negative 2, but it's less than or equal to positive 2. So what's inside the absolute value bars could truly be less than or equal to 7. That's case 1. Now case 2 we've got to think about for just a second. So we're going to take the absolute value of something, and I want it to be less than or equal to 7. So what could be underneath this square, underneath this absolute value? Well, it could be a 6, 5, 4, 3, 2, 1, 0, right? All that makes this true. Or it could be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, or stuff in between them, right? So what's underneath the radical then?
So you gotta flip this up.
What's underneath the absolute value bars, inside the absolute value bars? Have you not noticed I've messed that up 3 times now? That's obviously something I'm going to do. What's inside the absolute value bars is going to be dealing with negative 7. But we need it to be bigger than negative 7. So it's going to be bigger than or equal to negative 7, or it's going to be less than or equal to positive 7. And then we solve. So negative 4x is less than or equal to negative 1. I divide by negative 4. That tells me x 1/4. And I have to flip the inequality because I divided by a negative. Then over here I'm going to get rid of the 8. It's going to become negative. So negative 8 minus 7 is negative 15. Now I need to divide by negative 4. That tells me x is less than or equal to 15/4. Now it tells me to write the solution set using interval notation. So x is bigger than 1/4, but it's less than 15/4. Less than or equal to 15/4. So interval notation is where we put those braces. So the smaller value is 1/4. The larger value is 15/4. And both of those are included. And then if I had to graph that, okay, my points of interest are at 1/4 and 15/4. Both of them are included, so I put braces and I'm shading everything between them. Okay, it says Joe scored 72 on the calculus midterm. If the final exam counts twice as much as the midterm exam, then for what range of scores on the final would Joe get an average between an 81 and a 92? Both tests have a maximum of 100 points. Okay, so we're wanting what? We're wanting Joe's average to be between an 81 and a 92. So here's his average. We want it somewhere between an 81 and a 92. So bigger than an 81, but less than a 92. Okay, now how could I find Joe's average? Well, we know he's got two tests, a midterm and a final. But the final is counting twice as much. So to find the average, we would add up his scores and divide by
300.
we could do 300 or just 3. If you do 300, it's going to be a decimal, and you'll have to convert it.
Why are we dividing by 300?
We're not. We're dividing by 3. So the average is a 72 plus, what do you make on the final?
X.
X. And it's counting twice as much. So you basically take 2 of those X's. And so that's worth 300 total points. So there are 3 total tests that they took, essentially, since one of them counts twice as much. So we want to divide this by 3. Because that gives me the average. Now we want to solve. So x is being divided by 3, so we're going to multiply all of these by 3. So 81 times 3 is 2. 43 is less than 72 plus 2x, which is less than 92 times 3 is 276. Now subtract by 72. So that is 171 is less than 2x, which is less than 204. And now divide everything by 2. So that tells me x is greater than 85.5, but it's less than 102. So to have an average of between an 81 and 92, he needs to make between an 85.5 and 102. Okay, but he can't make 102 because it tells us the maximum is 100. So he needs to score between an 85.5 and 100 because that's his maximum value available. Okay, this says Yolanda is shopping for a used car in a city where the tax is 10% and the title and license fee is $360 is what we're going to go with. I can't tell what that is exactly, but I'm going to say $360. There is no tax on the title and license itself. If the maximum that she can spend is, again, your guess is as good as mine, let's say $6,180 is the max she can spend. Then she should look to buy a car in what price range? Okay, so let's figure out everything that's got to happen. So you've got the price of the car plus 10% tax plus $360 license fee. When we add all that together, she can only spend $61.80. So we need that to be less than $61.80. That's what we're looking at.
Or equal to, or is it just less than?
Yeah, to be less than or equal to. Okay, so right here, I don't know how much y'all have done with sales tax, but basically the price plus 10% of the price is 110% of the price. You just add those together. 100% plus 10%. So 110%, we could write that as 1.1 for 110%. 1.1p plus 360 has to be less than or equal to 6180. And then it's just like all our other ones. We're solving. Subtract 360. So that tells me 1.1p is less than or equal to 5820. Then I want to divide both sides by 1.1. So that tells me p is less than or equal to $5,290.90. 91 cents. What's our round?